Hi, Sportster Paul here. Today we're going to get a Creality CR10-S5. That's a 500 millimeter giant 3D printer. And we're going to replace the bed heater, not with the one when I bought the machine. I got this one, which is a little bit bigger, but a full bed heater. 510 by 510 millimeters. You can see, this is going on eBay if somebody wants it. Here's the metal bed. Here's the bed heater they've got, which is this bonded thing with I guess an aluminum heat spreader plate. Here's the problem why I'm doing this. Trying to print these big Harley Sportster aftermarket engine design I did. I have to put it sideways, or not sideways, about a 45-degree angle so it fits. It actually won't fit this way or this way, but that's okay. But you can see it's so far away from the heat right here where there's not a lot of structure. How can I show you? Here, up here. So this is the top when it's printing. This is the part that's against the glass bed. And let's see if I can get this. Hey, it works. I don't know if you can see it here. How can I show you in this camera? Right here, it's curved out. It lifted. And eventually it kind of gloms on. Let me show you. Maybe this was a good way to show you. So, because the heat isn't uniform across the whole, when there's a section like this, it's got like a thinner section, it wants to pick up off the bed. So there's other tricks we can try, and enclosure comes to mind. But for now, we're going to put the bigger bed on. When I bought the machine, I bought this one. It plugs into 110 instead of into the back of the box, the CR10 box. So it's a separate power. You got to figure out how to set this separately. Don't let the fact that the thermocouple that goes into the back of the box doesn't work anymore. None of that's connected. So you got to kind of fool the software into saying, oh, the temperature can be 20 degrees or whatever. Not a big deal. So this one, like I say, going on eBay. Let's get rid of it. This is the one we're going to use. Now, first problem, don't panic like I did. What I did is I set this down and I took the pad and I set it on top and I said, oh my gosh, they warn you in the eBay or Amazon listing, which I'll put down. My buddy's got an affiliate link. I'll put that down in the description. Oh my God, I only got a couple holes and I'm panicked, and it's like, it was, I don't know, it wasn't cheap. About $200 if I remember. Oh my God, big mistake. Well, no, it doesn't go like this, right? This surface doesn't glue to the top. This surface glues to the bottom. And if it's coming the heat out here, let's put it out here. So it's the same. And now, let's see how's the sky, where's our sky cam? There it is. Now you should be able to see, good, everything's lining up. Now, the headache, the factory one is just a plate, screws on, we'll take it off, first thing we'll do. This one's a little tricky. You got to peel up some gooey stuff. My theory is going to be, I'll flip this plate over. My theory is going to be peel this strip right about here, back, fold it. Hopefully, maybe I'll put bolts or something, locate the two holes as close as I can, stick this edge down, get underneath, start pulling the paper, hopefully without stretching the silicone, start pulling the paper, and in theory, everything should lay down and the holes here will line up. If they don't, that's going to be pretty rough. So that's the challenge, okay? So my buddy did this. He lucked out. He just plopped it down, and he said he moved it a little when he got one corner. I'm going to try for the edge. So getting it off the printer, much easier than I thought. You unscrew the little cable thing from the back of the control box. Then you just take the little adjustment wheels, the little 4 springs. Here's a couple of the springs, right? You unscrew the leveling system, and the thing just picks up. And these 4 long screws are left dangling. As a matter of fact, as you unscrew it, you might have to hold it. Of course, because nothing goes well in anything worthwhile, one of the things broke. A little segment broke off. See if I can take a picture of that. What did I do with the camera? Here it is. Here, we'll show that, and we'll show how that's a super glue job. It might not have taken. There we go, the happy sound. So, in addition to the springs, they give you washers. Now, bear in mind, when we put this down, let's flip this over so you can see. It's going to change the height of this printer because this sandwiches here to here. If the springs don't line up right, if the hole here isn't clearanced right, it might sit up a little higher. Maybe not. It will also make this clearance, so we're going to have to check that real careful, push it back. This clears the motor. I took a picture after I took this off so you can see why this big slot here, cut in the frame, is important. So the first thing, let's do this. First we'll draw with a red marker, Sharpie. There, we'll go 1, 1, 2, 2, 3, 3, 4, 4. Now we've located, what we haven't done is located, I assume the thing is square and symmetrical and it can go 90, 90, 90 degrees. Maybe not. For that, I'll put these links, my buddy's affiliate links, DYKEM, which everybody loves from the red stuff machinists use to lay stuff out. There's also blue. This is DYKEM paint marker, Brite-Mark, a thin one and a thick one. Now, marking here isn't going to do that good because this big red thing is going to go down over it. Of course, it won't really matter. We only need to know to get the heat, the wire coming off of this right. But to deal with these, so I'll put this here. You shake them, hear that? And then the spring-loaded tip, and then you finally get white. These are useful for a million things, like putting plus and minus marks on the black little boxes for batteries so you can see where the plus and the minus, because nobody bothers. I also, here's a picture of my wireless, or whatever you call it, my router, which I could never understand until here's a picture of the NAS, the network storage box I got. Just DYKEM, fantastic, white paint. They come in multiple colors, thin, thick. So while we got the thick one out, we didn't need the thin one. This is to turn the cameras on. Are we recording everywhere? Looks like we got audio, yeah? So because the red stuff's going to go over here, let's mark the edge of this with. So you can press it in like this. This works on your fingers, great. I do this real time. I mean, I could have practiced it and, oh, look how easy, I'm so smart. No, let's do it like everybody has to do it, with misery. Okay, so this is going to be about as good as we're going to get. And it is paint. It dries. Okay. So, I think we're done with our writing instruments. So I'm going to get another, wipe the paint off. We got the screws here. So, first thing, take this red block off, take these 4 screws out. Of course, they're 2 different sizes. If things serve me correctly, 2.5 millimeters, 2.5 millimeters. This is this one. Oh, I didn't bring a cup for all this stuff, darn. Come on. So that's that. It's nice when you make your videos, because if you do forget how to put something together, a lot of times you can go watch your own video and say, oh yeah, that's where that goes. Come on. This is wire tied on, so it's not going anywhere. It's got to be metric, right? The whole machine's metric, although I wondered, because some of this stuff fits really sloppy, to the point I'm not going to put the ball end in here. See, look at how loose that is. Can you see that? Skycam show it. That's nonsense. All right, so let's go with the solid end. Make sure it's down, get it loose. What's this up on? Good gosh. Oh, a spring rolled. It's pretty flat. I'm going to do, when I get this is just going to be getting it put together. The next video, next 3D printer video, I'll be making other stuff, but will be firing it up and trying it out. From that first video that did so well, I got like 10,000 views on it. I made some changes, like putting little strips of tape to get the glass level. No, that's something's going wrong with the adjustment. This 4-screw thing has just got to go. The fundamental design deficiency, and this is a brilliantly designed printer. Ooh, there's little washers, be careful. Let's put the little washer here. I try not to fast forward. I'll fast forward when I do this periphery stuff, but I figure you can fast forward the video, right? If it's going too slow. But it's nice to, kind of like an unboxing where it's real time and you know exactly how long it's going to take. Now, I don't know what I'm getting into. I didn't watch any videos. Oh, how about that? So, I mean, you really got to be careful picking stuff up by the wires. All right. So that's that. It is metal. We'll put this over here. Oh, well, this is a good opportune moment to show you. Right? So it came with the printer. It was a Creality option. I think I ordered from SainSmart. I didn't like their printer filament, but otherwise not bad. So we got the notch marked. We got the notch marked on the edge and paint. We kind of remember, let's put the back, or maybe we should just do it like real. The back is towards the back. Now, if I remember right, the 2 millimeter for these little ones goes back, and we're back to the 2.5. Guess if I was a cool guy, well, that ain't gonna work, is it? Okay. Like I say, I don't like using the ball, even if I was strong enough. I might pause the video here so you don't waste a lot of gigabytes of memory card doing something that's fairly straightforward, right? You folks get it, right? Go around here. I'm going to pause the video if I can find it, our little remote. I'll be back after I get the frame off, all right? Okay, we got them out, set them over here. Here comes the plate. Here's our white. Can you see it over me on this one? Here's the white paint. Shows where the back of this thing is going to be. A nice little feature I didn't realize. This frame bolts together here. So with this slot, we can leave this. Let's put it, I don't know, down here, out of the way. I could put it in Memphis. It would still get in the way. So now we're getting close. So here's that notch. So the back of the printer is here, right? You got to be careful. Don't, I don't think you want to stick it like this. It might not even fit. Let's look. See if this thing is symmetrical. Interesting, they cut holes for that old heater plate. That's kind of interesting. But I'm pretty sure the design intent, as we say in the engineering trade, is that this thing goes like this. Where's our frame? With, this was the notch. This is the back edge of the bed. This points back. That's going to be life. Where's our thing? Here's our notch here, right? That's going to go here. And what will be interesting is with this thickness, it's not that thick, but are these going to be long enough? And be very careful, maybe a little Loctite on these because you're not going to get a lot of thread engagement anymore. But then this is going to go like this, and this is moved off. So let's see, if the spring fits inside the hole here, see if you use a washer, that's going to kind of set the bed up a little higher when it's flipped around, right? Got to think about all this. So you don't plunge that extruder into the bed. So you can tell I'm kind of cogitating and putting off the ultimate fear. I guess the thing to do. See, I've thought about, here's the long screws that for the level adjusters, right? I thought about putting them up to kind of help me locate. Let's try that. If we put one here, and we put one, oops, come on, here. Will that make it easier maybe as you come down? Kind of gives you, oh man, they're not very close just to begin with. Let's see if we can, if we put a dead center there, see it's not right. Is it like, well, it's not going to stretch. So, okay, now split the difference so the bolts are a little towards the outside. Oh, see, it's right on the edge here. That might be enough. You know, I think I'm changing my method here. Changing my method. Let me stop the video and be back with a interesting piece of hardware. I'll be back. Okay, folks, we're back, almost live. I gave up on having stuff here to locate it because the holes are all kind of all over the place. Occurs to me the 4 important holes are the leveling holes. Here, 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 and here. How's this DYKEM doing? Can you see that? Maybe not so well, because and you want those, I want those as centered as they can be so that the spring fits in there. The washer won't, interestingly enough. And that may help us, it may hurt us, but at least we'll have a choice, right? We can drop the spring directly down, we can drop a washer down. So that'll be good. The other holes just have to clear to get a little screw, and hopefully these screws will be long enough. I went and got, first I got a big heavy thing, this backup battery, because that's another project for this printer, is in Florida the power quality is constantly going out. So can I make some kind of battery backup system? I got 2 of these that will actually keep the bed heater working. And that would mean instead of running this on 110 volts, maybe I run it on 24 volts. And can I get enough heat out of it? A whole other project. For now, I went and got, you know, the little edge clamps, the paper clamps that they give you to hold the glass top on this bed. I got the 4 of them from the printer. I put them right here and kind of, you can move stuff a little bit, right? And I got the 4 holes here as close as I could. Now let's try, we'll do double belts and suspenders, as the British say. Now we can go here and pull this back, pull this back. Get off of these holes. Get off of these holes and make sure those 2, I haven't moved it too much. See if I can fold it. This could work out well or not. There. Okay, it's in. It's going to be too late to do anything. I haven't done it upside down. We can get rid of that battery. We can take the clips off. At some point in time, you just got to say go for it, right? Now, oh yeah, let's... Well, if it just flops down, we'll be easy money. This has got to be a little better. Let's see if I can do it like this. Get both hands on under here. See, same thing. I'm trying to, this thing won't stretch. It's got, you know, wires in it. So I'm not seeing it stretch a lot as I pull this back. I don't want, oops, there we're going, screwing it up. See, it came to a hole and started to split. It's not as sticky as I feared. It's not like, I thought it was going to be like doing Formica countertop, if you've ever done that. That contact cement goes, it's on. So this isn't as nasty as we thought. Oop, we got to screw up here. Like I say, I'm amazed how easy this stuff comes up. Okay. 3M, it's good stuff. Minnesota Mining and Manufacturing. I'm a Midwestern guy, so I like seeing that. Got a little too fancy trying to hold it up because I am not sure. See, I really, now let's make sure. As much as we can take it up, down it comes. Magnificent. Magnifico. I used to have a roller for when I made circuit boards. I'd make circuit boards in my own little shop I had. You could roll, where'd that go? I'll have to go look for it. Meanwhile, success, because the 4 holes for where the springs are going to sit have plenty of clearance. It was a lot easier than I thought. I thought this thing would just touch and be, because it was said 3M, and we know how good 3M stuff is. Maybe it's counterfeit 3M. I'm going to go, gosh, I don't even know where I'd have that. Somewhere I've got a roller. I'm going to go find that and roll this thing, or maybe just get, a bowling pin or something and do it. I'll be back next. Well, can't find a little roller on a handle that I used to have. I'll find it when this video's done. Just some caulk or something. Let's do it this way. And we'll get there. Is the white here? Yeah, I guess I did it right. I assume this goes to the back. Didn't come with any instructions. And there's a couple of these on Amazon. One had a long lead time, but it looked more like it was local, but it's like $300. This one was much cheaper, looked to be the same, comes from Hong Kong, which actually works amazingly well. It's astonishing how quick stuff gets here. I've never lost anything. Okay, let's call that. I would like to think the heat will, like if this thing sags, oh man, then there's going to be more engineering, maybe figuring out, can I take this plate, you'd have to rip this all off, cut a hole in it to pass this, and then stick it, so that it picks up these holes. That wouldn't be a bad idea, would it? I do have a CNC machine. You don't even need it, right? Just hack a hole out here with a hole saw or something. It seems pretty good now. It's not overcomplicated, and you don't want to add mass to the bed if you can avoid it, right? If I could figure out some of my theories about how to do this is to get a thicker piece of glass, it's optically flat, float glass, glue this right on the glass, eliminate this aluminum plate, are there ways you can do that so there's plenty of engineering fun. Like I say, I don't want this thing sagging, so forgive me if this is too it'll be okay where the frame is, right? All right. That was the frame that I said will get in the way. I could put it in Kentucky. Get a little coffee here. Sorry to be off screen. Here we go. All right. So this is going way better. The thing I was worried about is getting it lined up and not being able to unstick it. Ooh, it's sticky stuff. So slot, white thing. Are these going to be long enough? What was this? This was the 2.5 size. Come from underneath. Can you see me? I guess you can see me doing this. Look at that, I got it first try. This can't be. How about that? Okay. So we got that one. It occurred to me, I thought, you know, these little short ones that mounted the old heater, I thought, well, I could just put them here to keep them there if you ever want somebody in the future, but they'd stick out too far and the glass bed wouldn't line up. Oh, this is heaven. Okay, so now we should be able to find this one. And it turns out, like I said, to me the engineering on the Creality is impressive because it's so cheap, right? Making a Rolls Royce isn't hard. I was an auto engineer. Making a Vega, that's hard. Making a Corvair, that's hard. So I'm quite impressed that they can make so low cost. Now this heater is a problem as far as a design problem. You know, not a quality, there were quality control problems. One of the pulleys was loose. Okay. So, I guess, where do we have some side cutters? Should be able to get this here, get this here. And if we do things right now, I am not, what's this noise? So same deal. I'm gonna turn the camera off. Oh, not this, let's get this corner. Doing the far corners. These countersunk screws, now that's bad engineering, but they probably didn't know that. I worked in military contractors, jets, radar pods, stuff like that. The problem with these countersunk screws is, depending on the clearances, you know, if they're a little tight on one side versus a little tight on the underneath of the other, they'll either tighten under vibration or they'll loosen. So that's why in fancy military stuff, they have a little caged nut when you've got these countersunks and it locates the caged nut. As it is, we'll be okay. I'm gonna put them in all real loose, go around, and then we'll snug it up, maybe with the ball, but not too much torque. It's obvious, you know, there's a glass top. You can see if they start backing out, all right? Okay, back in a flash. Okay, we're back and I'm upset because remember this little adjustment wheel that cracked and a chunk broke out? Here's some pictures. You could even see the little sinkhole, the little air bubble that caused the crack. So I figure, how about Loctite plastics and a $500 die grinder and a jet drill, because it felt liquid and it finally did get a little liquid. And okay, that's a half hour. And then this thing, the activator that you're supposed to rub on the stuff before you glue it together, dry as a bone. Dear Mr. Loctite President, one use, tiny minuscule things, because none of this stuff lasts more than once. So let's put the jet drills away. I'm always try to be good about, especially when you get upset, put stuff away. We're done. I put it together. Did I even get to that yet? I put it back together. Now I got to find here. Let's start putting stuff back. Okay. The top for that plastic Loctite. So then I went brand new. See, because you could only get one use. You know, why do you spend $7 or whatever? You get one use out of all this stuff. So let's try. I'll probably glue this thing to my fingers. All right. Now this one is some Satan where, see, maybe that's it. You screw it in and that punctures something. And now oops, look at that, gel coming out. Well, don't you love it? All right, so. And we'll put some on this side. I'm getting a little messy. Let's just hope for the best. And try to figure this mess out. It goes like this. That should be fairly straightforward. Got it. And maybe you can use your finger, you'll glue your finger. Oh, I already am glued my fingers together. All right. So I did get a little, oh well. So I don't think, see, none of this stuff. I got the best technologists in the world trying to make a reusable Loctite. I've never been able to. So I'll go buy a brand new one of these when this one is dry a couple months from now. All right. And peel off. What's this? Oh, that was from a plastic Loctite. So there we are. It went pretty good. I used a 2.5 millimeter Allen Bond House ball end. Went around, did use the ball end because it's, not a lot of torque. It would be easy to rip things apart because there's fewer threads, right? Because you've spaced out that bar. So you can see, here's the underside. Let's flip it over. Feels pretty good. Let's flip it over. And see, they say, oh, I should have mentioned that at the beginning. Sorry. You're not supposed to turn these on with no load, with no, what do you call it? No metal plate, right? Apparently it doesn't like, let's put this here. Let's get this guy here. Oh, you think the universe could agree on a standard plug? Jesus. Excuse me, Lord. All right. Here we go. Keep our parts together. It's still a little glued. Oh, here's a good opportunity to get rid of our white pens. Put them pointing up. Always good to keep the toolbox ready. Oh, it's got a little, it says 27.4. Can you see it? 28.5. Oh, it's warm. It had a set point. Glad I didn't plug this in. Look, everything's glued. Super glue is everywhere. The longer screws I could screw in as a placeholder that was holding that little block, this little red thing. This little red, can you see it? So maybe we'll do that. It's up to 36. Let's press the set button. Oh, it's set to 80. That's actually not too bad. Press it again. Okay, now it's going back. Oh, this is cool. Oh, God, it's so quick. And it does feel uniform. I am going to stop the camera, run and get an IR sensor. It might take a little bit while to get working. And let's see how uniform it is. I don't think I can hurt anything heating this mess up to 80 degrees centigrade. Actually, that's a little hot. Set, go down. Ooh, nice clicking. Some of this Chinese stuff is so nice. Let's do 70, because I'm an electrical engineer, and 0 to 70 is a common electronics temperature for components, right? It's rated to work between 0 and 70. 70, you can't hold your hand, like right now, see, I can't hold my hand against it. It says it's 60. I'm gonna stop the cameras, go get an IR sensor, and we'll be right back. All right, we're back. By the way, bad practice to have something that can run away thermally and to go walk around the house and look for stuff. You might come back to a fire, but I think we got away with it. It says 72 degrees. Now it's back down to 71. I got my little Fluke, what is this? Fluke 80T-IR and a Fluke 189 True RMS multimeter. It says 24 now, just what you'd expect. In the center, 68.8 degrees. Out by the adjusting hole, 63. Out in the far corner, 59. So 60 to 70, I guess, right? Not even. It's more uniform than I expected. This is great news. 63. I can hear this thing clicking. It must have a relay instead of a solid state relay. 65. Middle. It's a nice flat black mat. You know, if you go over a shiny screw, it should, 37, because it's shiny. The, not iridescence, what is it? Irradiance is different. But nice flat black thing like this, perfect for an IR sensor. 68.8. This says 71. Over here, 63. So if there's a 5-degree difference out to the corners, this is way, way better, because I used the same thing back when we had the original little factory one, and it was hardly any heat out here. So do the, always good to, as long as you don't electrocute yourself or scald yourself. 70 degrees that was the rule of thumb in the military contractors I worked with, because there the temperature is 125, which is over boiling water, which will damage you. But some of the old timers said, well, 70, you can't hold your hand on it. And I agree, if this is to be believed. 66, 67, 68, but relatively uniform compared to this. I am a happy camper. Put this away. Now, how do we turn this off? I guess unplug it, right? That's kind of goofy. Or set it to nothing. Set. Let's try this. And go down. Now, you got to hold it for quite a while before it auto scrolls. 40, 30, 39, 35, 36, 37, 20, 24, 22, 20. Let's get it down to 6 degrees centigrade. So it should turn off now, and it should cool off now. Although it looks like the smart thing to do is unplug it. 68 degrees. Should cool off pretty quick. Can I touch it? Tenths of a degree are dropping. So I think I cut power off. I'll unplug it. That'll be the simple thing. So I'm delighted. Now, like I said, I'll do first try. Let's see if I can get better results. The biggest problem is right here where it picked up. Where can I show you? Nowhere, I guess. It's hard. You can kind of see it there, right? How it curves in. It's like 4 or 5 days to print this half. So hopefully we'll get that dialed in. Like I say, this whole leveling system is Mickey Mouse. That's the one design. You shouldn't have to level things, right? If the machine is any kind of precision, true, you just, if you don't touch it the next day, it should be right where it was, and you can do a first layer and everything will work. That's not going to happen on an inexpensive machine. The 4 pull downs, I can't do it without warping the plate, and that's why I was putting the tape in between the glass plate and this surface. That's got to stop. I went once the tabs underneath and I bent those so that I could just reef these screws all, because my buddy Dave, the mechanical engineer, says, well, don't leave these loose and sloppy, because then as it goes back, it kind of shakes. It racks the bed a little bit. You want these reefed down. As you reef them down, all the forces go up. You tend to warp stuff. The other thing is the base. I had much less trouble when I did that last video. I'll put a link down below. I put it on this desk and, hey man, this leveled right up. It's great. I got the camera running. It worked good. But I had a lot more trouble because I had it on a darn coffee table, right? And that flimsy frame of that CR10-S5, it's all over the place. So then I went to Home Depot, measured stuff, made a 3/4 inch piece of plywood, cut it to size, laid that on top of the card table, little Walmart card, those fold-out card tables. Then put the CR10. Then actually got some shim stock and tried to make sure that it wasn't racked and warped. And then you go and do the rest of the stuff. You're making sure that the gantry arm is level compared to the frame. And then you level the bed to the gantry arm and all of that. One of the commenters, something that helps a lot, you don't put the extrusion head here and adjust here. And you don't put the extrusion head here and adjust here. You put the extrusion head as close as you could to where these adjustment, spring goofinesses are. My buddy Dave, mechanical engineer genius, he said some folks are just, trying to get shims and they're just reefing the thing down hard. I'm going to kind of look at doing that. There's interesting thermal issues. This thing moves around a lot. You calculate the thermal expansion of aluminum and how much it moves. There's a lot of growth, right, in this aluminum plate as it heats up. That's why the silicone is good, because it'll stretch a little bit as the aluminum stretches. So we're going to play. That'll be the next video. This will be mounted. It's fairly trivial. You got to fool the software so it doesn't say, oh, there's no temperature. And I used to be, I got to 70 and then I started working. You got to fool the software and say, oh no, you can work at 20 degrees or 10 degrees. So it starts, but then you got to make sure that you've got this all set up and turned on. So yeah, it's down to 56. So we turned it off. I'm very happy. 100, whatever, $200. So back in the 3D printing world, I will let you know how that goes. Stay tuned. We're going to be doing a lot of different videos, but when I get this put back together, we'll try to get some first layer and see if we can do better with the whole leveling and solidity and all of that. I moved the printer, I brought it out here, did video, moved it back, then I moved it again because I bought a CNC machine so I can machine plates and do things like that. Another printer project. The little frame on the CR10, that big, 19-inch by 20-some inch, big slab of Mech 6 flat, 3/4-inch aluminum. It's only $120, $130 from the metal suppliers. And substitute that and use my CNC to drill it for the gantry and the motors so everything fits. So that'll be a fun project. So we're having fun. This went way better than I thought it would. So got a little glue on here, but that won't matter. All right. Catch you next time. Sportster Paul. Have fun.